So kinematics is the study of motion in the absence of forces. This is like position, velocity, acceleration, where there can be under the influence of gravity, but there's nothing else pushing or pulling on them. So an example of this is a car. So let's say a car is moving at some speed, v of t, then we can get acceleration, or we can get position. We can calculate all of those without needing to know forces. And specifically, we're going to start with particle kinematics. So a particle just means to simplify the object so that it's just a dot. Size and shape do not matter. So whether the object is a box, we say all the mass is concentrated at the center. It could be a circle, everything's concentrated at the center. It could be a car. We're not going to differentiate between front of the car and back of the car. We're just going to say the car is at the dot. So in a place where size and shape don't matter, then you don't have to worry about tipping and you don't have to worry about wind resistance. You're pretty much just concerned about where is the object and how fast is it moving. Questions? Okay. Now, these things, position, velocity, acceleration, and time, they're all related to each other. So the four variables to keep track of. The four variables that we're going to deal with are going to be position, velocity, acceleration, and time. Sometimes S is, or the variable R, is used instead of S. But there are four equations that can relate all of these to each other. And so basically you just have to pick which equation to use. So these four fundamental differential relationships. The four relationships we need to know. The first three use time. So we can relate position to velocity and time. We know that velocity equals ds dt. Velocity is the derivative of position. So if position is in meters, velocity and time is in seconds, velocity is going to be in meters per second. So a lot of these relationships you can figure out, which is based on the units. So the next one is acceleration. Acceleration is the derivative of velocity. So that is the second derivative of position, or dv dt. Or if you don't have time, but you have the other stuff, there's a fourth one. So we know that dv dt is the same as dv ds times ds dt, right? Because if you cancel the ds's, you get dv dt. But this is v. So we can also say A equals dv the s times v. All right, so 1, 2, 3, and then 4. Each one of these relationships uses 3 variables. So pretty much, if you know 2 of the variables on this list, you can figure out what the other 2 are. So you know position and time, you can figure out velocity. If you know, or if you know position, time, you can figure out acceleration. Or if you had velocity and time, you can figure out acceleration. Or if you had velocity and position, you could figure out acceleration. So you only need 2 of these to find the 3rd and the 4th. You just pick which equation you want to use, and you separate and integrate to solve, or you take the derivative. So here, if we start with position and we want to find acceleration or velocity, we go down the chain, take the derivative. But if we have acceleration and we need to find position, we go up the chain, we integrate. So the key to solving any of these kinematics problems is just figure out which differential relationship you need to use based on the variables, and then integrate or derive to get to the answer. So here we did kinematics is motion without forces. The particle is when size and shape do not matter. And we learned how do you get position, velocity, and acceleration by taking derivatives and integrals using these 4 fundamental differential relationships. And if you note, all of these are scalars here. That means they are one-dimensional. So this is for rectilinear motion. So there are different types of motion, but rectilinear is one-dimensional. So motion can be divided into rectilinear and curvilinear. Rectilinear is one-dimensional. Curvilinear is 2 or more dimensional. So for this, we use S for curvilinear, and these are scalars. So for curvilinear motion, position, velocity, and acceleration all become vectors.